and the next is vector physical quantity. Okay, now we can divide them in another way: fundamental and derived quantities. Now, fundamental physical quantities, they do not need help of any other quantity to define themselves, like time, length, mass, temperature, amount of substance, right? Do you remember those 7 fundamental physical quantities, Bachu? Do you remember all the 7?
Yes.
Length, mass, time, current, temperature, amount of substance, luminous intensity, right? These 7 are the fundamental physical quantities which do not need any other, which do not need support of any other quantity to define themselves. But the derived physical quantities need help of more than one fundamental physical quantity to express themselves. By using these 7 fundamental physical quantity, we can represent anything which exists in the universe, including from force, work, energy, anything, magnetic field, flux, whatever you think, we can represent by the combination of these 7 fundamental physical quantities. Okay. Now every physical quantity have its own unit except one. What is that physical quantity which have unit and do not have dimensions? That every physical quantity have unit, but there is one physical quantity which have only unit but no dimensions.
Angles.
Correct. Note, angle is the only physical quantity which have unit but no dimensional formula. Now, what is this dimensional formula? Representing any physical quantity in terms of m, l and t is known as dimensional formula. Okay. अब इसमें तुम लोगों को कोई डाउट नहीं होना चाहिए, right? I believe you know what is this m, l and t, right? Dimensional formula and all.
Yes.
Like for example, now you can write heading dimensional analysis. Dimensional analysis. Our next topic is dimensional analysis. Now, how to understand this dimensional analysis? Like, take example of momentum. What is formula of momentum? P is equal to mv. So write the dimensional formula of mv. So at mass, capital M will represent mass, and for the velocity, the formula of velocity is displacement upon time. So length will represent displacement and t will represent time. So we can say that m1, l1, t minus 1 is dimensional formula of momentum. Could you understand that? Everyone understood?
Yes, sir.
In the same way, can you write dimensional formula of force? F is equal to ma. So when you want to write dimensional formula of force, at the place of m, you will write m, capital M, and the unit of acceleration is meter per second square. So meter means length and second square means square of time. So dimensional formula of force can be written as this. Agree, bacho? I will tell you dimensional formula of very, very important quantities. So please, if you can write, please write it. Now, do you know what I represents? Impulse. Impulse and momentum has same dimensional formula because impulse represent change in momentum, right? And P represent momentum. So change in momentum and momentum have same dimensional formula, right? Any doubt in that? Impulse and linear momentum must have same dimensional formula. Force. And then we can talk about pressure. Pressure and stress have same dimensional formula, but they are different. Okay, pressure and stress may have same dimensional formula, but they are different. Force upon area, you take different area. When force is perpendicular to entire area perpendicularly, it is called pressure. But when force is perpendicular to any particular area of cross section, it is known as stress. There are 3 types of stress, I believe you know. पता है ना तुम लोगों को? There are three types of stress. Dimensional formula of force and dimensional formula of area is L square. So you can write it M L minus 1 T minus 2. This is dimensional formula of pressure. Okay. Pressure and stress have same dimensional formula. Kinetic energy, potential energy, work, heat, and energy stored in the capacitor, work done in transferring a charge, Q delta V. जो भी तुम लोग को याद है सब यहाँ लिखते जाओ. I square R into T, heat, it represent heat. ms delta T also represent heat. जो भी तुम लोग को याद है, Q square by 2C. Anything you remember in the form of energy you can write here. Work, right? Kinetic energy, potential energy, work, heat, total energy, total mechanical energy, total energy of any planet or any star or any moon. And you can write mgh, potential energy. Okay, these all have same dimensional formula equal to dimensional formula of work. One more important, torque also have dimensional formula equal. So these all quantities have equal dimensional formula, and dimensional formula must be equal to what? M, speak, come on.
ml square t to the power minus
L square t to the power minus 2.
Correct. So from where we got this, see, read this. Work is equal to force into displacement. Work is equal to force into displacement into cos theta. So force has dimensional formula M L T minus 2. We derived this already. Displacement have dimensional formula L, and cos theta is based upon height, based upon hypotenuse. So both have dimensional formula L, because base is also a kind of length and hypotenuse is also a kind of length. So cos theta is actually dimensionless. So you got dimensional formula of work as this. Could you understand that? So you can write here cos theta is dimensionless. All trigonometric ratios and angles are dimensionless. Understood? Copy fast. All trigonometric ratios and angles are dimensionless. Okay, you can copy this. Done? आगे बढ़े?
yes sir.
Okay, now we talk about dimensional formula of density is very important. Density is equal to mass upon volume. Mass means m and volume means L cube. So dimensional formula of density is m L minus 3. Very important. And the next, can you tell me what is dimensional formula of angular displacement? Angular displacement. What will be dimensional formula of angular displacement or angle? Just I wrote.
Dimensionless.
Correct, because angle is equal to arc upon radius. Do you remember this formula? Arc is also kind of length and radius is also kind of length. So it is actually dimensionless. This and this, I already told you, dimensionless. Can you tell me dimensional formula of angular velocity? Angular velocity?
T to the power minus 1.
Angle upon time. So dimensional formula of angle is dimensionless. So t power minus 1 only. That's it. Because theta is dimensionless. Could you understand that? Okay, now tell me dimensional formula of angular acceleration. Alpha.
Power minus 2.
T power minus 2.
Omega t by t. So t minus 1 upon t. So t power minus 2. Dimensional formula of angular acceleration. Okay, keep copying. Dimensional formula of moment of inertia, very easy. Moment of inertia I. What is moment of inertia? For a point mass, moment of inertia is mr square. Imagine a point mass performing rotational motion about this axis. So its moment of inertia is mr square for the point mass. If you write it dimensional formula, ml square. Could you understand that? No time. Time is not required to define moment of inertia. If we talk about angular momentum, hey, I forgot one thing here. Angular velocity and frequency have same dimensional formula. Frequency and dimensional and angular velocity have same dimensional formula. And now if you talk about angular momentum, we talk about angular momentum, that is L. What is angular momentum, bacho? MVR,
MVR.
right? So and nh upon 2 pi and nh upon 2 pi, where h is Planck's constant and n is a number and 2 pi is a constant. So where 2 pi is dimensionless constant, where 2 pi is dimensionless constant, n is a number which present order of orbit, right? Or principal quantum number. Am I right? So we can say that angular momentum L, L is not length here. L is angular momentum here. Angular momentum MVR, and if we keep only H, because 2 pi is dimensionless and n is a number. So they do not have any dimension. So Planck constant and angular momentum have same dimensional formula. It is a mass for the m, for the velocity length by time, and another L for the r, right? So they have equal dimensional formula. Angular momentum, Planck constant, MVR have same dimensional formula, ml square t minus 1. Could you understand that? Huh?
Yes, sir.
Now there is one more thing which have dimensional formula equal to angular momentum. Tell me what? We represent it by J. What is that? Angular impulse. Okay, angular impulse and angular momentum must have same dimensional formula. Any doubt in that? Any doubt till this?
Yes.
Okay. And please start practice also, bacho. Okay, if you keep attending my class only, it will not be beneficial for you. Please practice on daily basis. Okay. Now let's talk about the dimensional formula of spring constant. Spring constant. So spring force is kx, right? So spring constant has dimensional formula of F upon x m lt minus 2 upon L. Dimensional formula of spring constant is m t minus 2. Understood? If any doubt, please ask. Dimensional formula of gravitational constant, capital G. How to find this? Very easy. Imagine 2-point mass m1 and m2. Distance between them is r. G m1 m2 upon r square is equal to force. Now dimensional formula of force ml t minus 2. G को G रहने दो, m into m for the m1 m2 and L square for the r square. Now try to solve this. You got dimensional formula of G, L power 3, T power minus 2 and m power minus 1. Understood? Understood everyone?
Yes, sir.
Now
Yes, sir.
intensity of gravitational field. Intensity of gravitational field बताइए. Intensity of gravitational field means force on 1 kg. Do you understand that? Suppose you want to find intensity due to this, gravitational field intensity due to capital M at a distance r at any point P. Means you are talking about a force on 1 kg due to this. So force on 1 kg is equal to gravitational field intensity due to capital M. And it is given by G m1 m2 upon square of distance, and it is minus because this is attractive in nature. Could you understand that? So what is I? Gravitational field intensity or intensity of gravitational field. Could you understand that? Click on yes. Understood now? So gravitational field intensity is actually, Arshita, force on 1 kg. Okay, Anvit? So now let's try to write dimensional formula of I. The dimensional formula of G. You can ignore man, negative sign. G has dimensional formula equal to this T minus 1. Am I right? T minus 2 होगा कि minus 1 होगा बच्चों? Minus 2 होगा. Should be minus 2. This is dimensional formula of G, okay? M divided by L square. So dimensional formula of I. Bachcho, please cross check. You also getting same answer? M got cancelled, sorry. So there is no M. Is this correct? Or I did any mistake? No, I am correct. I am correct. सही हूं ना मैं?
Sir, what about 1 kg? Will not there be one more M?
Actually, that 1 kg is other side. You should talk like this. 1 kg is this side. Understood, Chinmay?
Yes, sir.
It is like that. Now, okay? That's good. कुछ doubt तो था कम से कम. We did angular momentum, spring constant, gravitational potential. Come on. What is dimensional formula of gravitational potential? What is gravitational potential at any point P at a distance r? How it is defined as? Same as electrostatic potential. The gravitational potential is equal to the work done in bringing 1 kg from infinite to point P. Could you understand that? Yes or no? The gravitational potential is equal to work done in bringing 1 kg from infinite to point P. Could you understand that? So work upon 1 kg is a gravitational potential. Could you understand that? So m L2 T minus 2. I believe this should be the dimensional formula of gravitational potential. Tell me if I am wrong. So this V is actually gravitational potential, and its dimensional formula is this m0. Understood? Understood, everyone?
Yes, sir.
Okay. Now next is surface tension. Can you tell me what is the dimensional formula of surface tension? Anyone remember what is surface tension? Force per unit length. Okay, so force per unit length is surface tension. Could you understand that? So mlt minus 2 divided by L. LL got cancelled, so mt minus 2. Okay, understood, everyone?
Yes, sir.
Okay, now next is velocity gradient. Velocity gradient. Now what is this velocity gradient? dv by dx. Okay, understood? So velocity is meter per second. The unit of velocity is meter per second, and this represent meter. So L by T upon L. LL got cancelled, T minus 1. So velocity gradient, angular velocity and frequency have same dimensional formula. Understood? Velocity
Yes,
gradient.
sir.
Velocity gradient. Please write this. velocity gradient, angular velocity, and frequency have same dimensional formula. It does not mean that these three physical quantity are same. No, they are completely different, but luckily they have same dimensional formula. Okay. We wrote already about stress, coefficient of viscosity, very important. Mark a star. Coefficient of viscosity. Can you tell me dimensional formula of coefficient of viscosity eta? For that, imagine water. Imagine this is water, and inside water, imagine a ball. Okay? Can you see this small ball? Can you see this ball?
Yes, sir.
This spherical ball is moving with velocity v inside this liquid of viscosity coefficient eta. Okay. So how much there will be a resistive force on this ball, isn't it? जैसे तुम bike चलाते हो, you feel a resistive force. Am I right? In the same way, there will be a resistive force on this ball, right? So this resistive force can be written as 6 pi eta rv. Could you understand that? This resistive force or viscous force, you can say, जब तुम गाड़ी चलाते हो तुम्हें air resistance feel होता है. In the same way, the water resistance is known as viscous force, and this viscous force is given by 6 pi eta rv. So let's by using this formula try to write dimensional formula of eta. So dimensional formula of force already we know, mlt minus 2, and 6 pi is a dimensionless constant. 6 pi is a dimensionless constant. Okay, so forget about 6 pi. You can ignore 6 pi. Eta, we don't have dimensional formula. And for the R, L, and for the V, L by T. Could you understand that? What I'm doing, L will get cancelled. So you can transfer other L this side, M, L minus 1, and T minus 2 into T. So dimensional formula of eta is M, L minus 1, sorry, and T minus 1. Could you understand that? Huh?
Yes.
Yes, sir.
There should be no doubt in the coefficient, in the dimensional formula of coefficient of viscosity. So keep in your mind how we wrote it. We cannot mug up it, right? It's impossible to remember. But you can keep formula in your mind because you can use it in the numerical as well. You can find dimensional formula as well. Can you tell me what is dimensional formula of strain? Now, what is this strain?
Dimensionless.
Change in length upon original length. This is longitudinal strain. We have three types of strain. This is longitudinal strain, change in length upon length. Yes, it is dimensionless, L upon L. So it is actually dimensionless. There are three types of strain: longitudinal strain, shear strain, and volumetric strain. So all the three types of strains are dimensionless. Okay. Very important, modulus of elasticity. Modulus of elasticity. Can you tell me dimensional formula of modulus of elasticity? Its formula is stress upon strain. I hope you remember. Do you remember?
Yes.
So there are three types of modulus of elasticity: Young's modulus, bulk modulus, and modulus of rigidity. Do you remember all the three? Shear modulus or modulus of rigidity? They all are equal to stress upon strain. Do you remember? They all are equal to stress upon strain, and stress has dimensional formula of pressure, that is m L minus 1 T minus 2, and strain is dimensionless. So now we can say that Young's modulus bulk modulus. What is name of eta? Modulus of rigidity, stress, and pressure. They all have same dimensional formula. Could you understand that? Any doubt in this? Hello.
No, sir.
Okay. Now write next Poisson's ratio. Poisson's ratio. What is Poisson's ratio? Sigma. बच्चों, when you stretch a wire, जब आप एक वायर को खींचते हो तो उसकी लेंथ बढ़ती है. Say yes. Stretch this wire, its length will increase or not?
Yes, sir.
But its radius?
Decreases.
Decreases. Okay. So delta R by R is known as Poisson's ratio. Understood? Delta R by R upon delta L by L. Sorry. I think this is Poisson's ratio. So this should be dimensionless. I forgot its formula actually. Anyone remember? किसी को याद है तुम में से? नहीं याद है? मुझे एक बार और सोचने दो. Longitudinal strain upon lateral strain means this is reverse. Delta L by L upon delta R by R. Delta L by L upon delta R by R. This is known as Poisson's ratio. So it must be dimensionless. Do you understand that? Okay. The next is time period and frequency. I think you know that. है ना? What is dimensional formula of specific heat? Come on, what is dimensional formula of specific heat? Imagine a container. Hello, am I audible?
Yes, sir.
Imagine a container and start boiling, start giving it some heat. There is some liquid in this. So what will happen? Temperature of this liquid will rise or not?
Yes, sir.
Suppose mass of the liquid you have is m. So heat given must be equal to ms delta t, where s is
Specific heat.
correct, where s is specific heat. So you can say that heat has dimension equal to work and energy. So m L2 T minus 2, okay? And m at the place of mass, and specific heat we don't know, and at the place of temperature you can write theta or K. What do you want? K or theta? K for Kelvin, theta for temperature. Both same. What do you want to write? You want to write K or K? Okay, K. K represent temperature. Okay, dimensional formula of temperature is K. So mm got cancelled. Dimensional formula of specific heat became this. This is m0 because m cancelled na m0. So dimensional formula of specific heat is this. Understood?
Yes, sir.
Now right next, thermal capacity. Thermal capacity. Do you know what is thermal capacity? Mass into specific heat, I believe. Thermal capacity is mass into specific heat. ms. So what should be the dimensional formula of ms? m L2 T minus 2 K minus 1. Am I right? Am I right? multiply by m into specific heat, you will get thermal capacity. So what is thermal capacity? Mass into specific heat. Could you understand that?
Yes.
Yes, sir.
Remember, latent heat, L. See, I'll remind you. Suppose you want to melt 1 gram of ice, you need 80 calories. If you want to melt 2 gram of ice, you need 160 calories. Do you remember? Suppose you have ice at 0 degrees centigrade and you want to melt ice. So the energy you need is known as latent heat to melt 1 gram of ice. Hopefully you remember ml. Heat is equal to ml, where L is latent heat of fusion or vaporization. I believe you remember this formula where Q represent heat. So ml2t minus 2 for Q, for latent heat L. This L is not length, this is latent heat. Latent heat. Okay, I believe you remember this formula. Got cancelled. So dimensional formula of L means latent heat is m0 L2 t minus 2. This L is length and the other L is latent heat. Could you understand that? Keep in mind.
Yes.
Now universal gas constant. Dimensional formula of universal gas constant. बताइए क्या होना चाहिए? What is unit of R? P. Do you remember PV is equal to nRT? This R. What is unit of this R? Anyone remember? I remember. Its unit is joule per mole per Kelvin. Because P into V has unit of joule. Okay. P pressure into volume has unit of joule. Okay. Could you understand that? And
Yes.
N idhar aa jayega, T idhar aa jayega, T will come other side. So what should be dimensional formula of this? R is equal to PV upon NT, right? So PV has dimensional formula of energy or of work. Okay, and the temperature has K. Number of moles, no dimensional formula. So universal gas constant has dimensional formula ml.
Number of moles.
Mole.
We write, but it is its unit, I believe. No need to write dimensional for that. Dimension नहीं है मोल के बेटा, वो तो symbol है. Okay. Name of unit or symbol like kg, meter.
Sir, amount of substance.
It is a physical quantity, but we have never wrote its dimensional formula. मतलब dimensional formula में जब mole आता है ना, तो we consider it as a number, so we can ignore it. Understood? We are not writing it. In dimensional analysis, there is nothing for mole. Okay. Now, right next, very important, Boltzmann constant. Boltzmann constant. K. Can anyone explain me anything related to Boltzmann constant? Any story you have related to Boltzmann constant? I have one story. सुनना चाहेंगे? Would you like to listen?
Yes, sir.
Imagine a monoatomic molecule. Imagine a molecule of a monoatomic gas. Okay. Who is this Apar? अनुष्का अपार नाम से आए क्या? चला गया. But Boltzmann constant is by using Boltzmann constant we can represent kinetic energy of a molecule of a monoatomic gas. So kinetic energy of a molecule of monoatomic gas is given by 3/2 kT, where K is Boltzmann constant. Okay. And T is temperature, K is Boltzmann constant, 3/2 is a number, which I'll explain you kt by 2 along x-axis, kt by 2 along y-axis, and kt by 2 along z-axis, 3 degrees of freedom. Do you remember anything like that? So kinetic energy of a molecule we represent by Boltzmann constant. So 3 by 2 is a dimensionless constant. So we can ignore. 3 by 2 ignore by. Why we should ignore this? Because this is a dimensionless constant. Okay, so you can ignore 3 by 2. And at the place of kinetic energy, what you can write? ml2 t minus 2. Am I right? 3 by 2 you can ignore. K is Boltzmann constant. And for the temperature, you are writing K, Kelvin. Okay. Do you remember? So ml2t minus 2k minus 1. Dimensional formula of small k, that is Boltzmann constant. Remember this. Very important for NEET and IIT. Okay. Copied?
Yes, sir.
Yes, sir.
Okay. Keep writing very fast. Keep writing. Now write Stephen's constant. Stephen's constant, sigma. Now, do you remember anything related to Stephen's constant, or you forgot everything? You forgot everything? You forgot everything about Stephen's constant, bacho? Anything?
Sigma EAT power 4.
Sigma?
EAT power 4.
Sigma E8T power. And what it represent?
E. Power.
Power. Very good. Power means heat radiated per second.
Second.
Means power. Okay. Suppose this is a hot body whose temperature is T and its area of cross section is A. Then it is going to radiate this much energy. And if it is a black body, what should be E? If it is a black body,
1.
from 1, so power radiated by a black body of temperature T is equal to sigma A T power 4. This is power radiated by a black body. Power radiated by a black body of temperature T. So let's start writing dimensional formula. For the power, you will write m L2T minus 3. Am I right? Work upon time. Could you understand that?
Yes,
Work
sir.
formula m L2T minus 2 divided by T. So you'll get this. Anyone want to ask how I got this? No. Okay. Sigma we don't know. Area L square, T power 4, K power 4. L square got cancelled. M L0, T minus 3, K minus 4. We got dimensional formula of Stephen's constant. Very important. Very, very important. Okay. आगे बढ़े? Yes or no?
Yes, sir.
Yes, sir.
All right. Next, Wien's constant. WIEN. Wien's constant. WIEN as Wien's constant. Where we use it? Where we use it?
Wavelength is inversely proportional to temperature.
Correct, correct. Imagine this is a hot body whose temperature is T. So it will emit radiations, no doubt. Hot body के पास जाते तो गर्मी लगती है कि नहीं लगती है? Because it is emitting lot of different wavelengths, waves, EM waves, yes, electromagnetic wave. Hot body radiates electromagnetic waves. तो उस electromagnetic wave की कुछ wavelength होगी. So wavelength is inversely proportional to the temperature of the body. अगर बॉडी का टेम्परेचर ज्यादा है तो वेवलेंथ छोटी है. So you can give wavelength is equal to B by T, where B is Wien's constant. Now, how to find its dimensional formula? B is equal to lambda into T. Okay. So for lambda length, for T Kelvin, everything else 0. So M0, L, T0, K. Understood? Understood, everyone?
Yes, sir.
Okay,
Yes,
that's
sir.
good. Good. Vishal, you are not clicking on yes. Maybe my speed is fast, but so let's it. Leave it. I'll teach you everything again slowly. Better you make notes. Okay, Vishal? And if you could understand anything, it's good.
समझा देना सर आप.
हाँ, ये तो मैं पढ़ाऊंगा, नोट्स भी दे दूंगा, बट लेकिन थोड़ा बहुत तो समझते चल, है ना, क्योंकि यही सब मुझे तुझे पढ़ाना है बाद में.
Yes,
आज नहीं,
sir.
है ना, सब पूरा का पूरा सेम. Planck constant we already wrote. Coefficient of linear expansion. Coefficient of linear expansion. Right? Suppose you have a rod of length L. Now you're increasing temperature of this rod, suppose. So it will start expanding and its length will become big. Am I right? Am I right?
Yes, sir.
So we can give new length is equal to old length 1 plus alpha delta t, where alpha is coefficient of linear expansion. So multiply L into the bracket, transfer this L other side, L minus L, L dash minus L is equal to L alpha delta T. So delta L divided by L delta T is equal to alpha. Could you understand that? So what should be dimensional formula of alpha? Meter for delta L means length for delta L upon again length for L into K. L got cancelled. So dimensional formula of alpha is only K inverse. Could you understand that? M0, L0, T0, K inverse per degree centigrade or per Kelvin. ठीक है बच्चों?
Yes, sir.
Okay. Now mechanical equivalent of heat is just a number. It's just a conversion number. Okay. Mechanical equivalent of heat is dimensionless because it just converted joule into calorie. It is just a conversion factor. Could you understand that? So it is also dimensionless. It just give us one information: 1 calorie is equal to 4.2 joule. Could you understand that? It is just a conversion factor. It does not have any dimensional formula. Okay, now we are moving into class 12 portion now. Electric charge. Electric charge. What is dimensional formula of electric charge? Come on.
A minus
AT.
Current is equal to Q by T, and for the current we are using A, T. So dimensional formula of Q is AT. Understood? Second is electric current, that's A, right? Third is capacitance. Can you find dimensional formula of capacitance in the most easiest way? I have one formula. What is energy stored in a capacitor?
QV by 2.
And this is also a formula. Q square by C, QV by 2, and CV square by 2. Please pick this one. It will give you direct dimensional formula of capacitor. Fastest way to find dimensional formula of capacitor. You can ignore 2, it's a dimensionless constant, into C is equal to Q square. So U is energy, ml2 t minus 2. C we don't know. Q square matlab A square T square. Understood? So dimensional formula of capacitor is M minus 1, L minus 2, T4, A2. Understood?
Yes, sir.
Yes, sir.
Copied?
Yes, sir.
The third is electric potential. Electric potential or potential of a battery. The easiest way to find dimensional formula of potential is VI is equal to power. See, you have different formulas for power, I square R, VI, and I square R, VI, and there is another formula I forgot.
V square by R.
V square by R. There are three formulas to represent power. Power consumed in an electrical circuit in which I current is flowing and with the help of a battery of potential V. Right. So I think this is the fastest way to find dimensional formula of the potential. So V and I has dimensional formula A and power is ml2 t minus 3. So dimensional formula of potential is ml2 t minus 3 a minus 1. Fastest way to find dimensional formula of potential is this. Okay. Done.
Yes, sir.
Permittivity of free space is 4. Epsilon naught. This is permittivity of free space. How to find dimensional formula of permittivity of free space? Imagine 2-point charges. What is force between them? Q1.
2 by R square.
No, not K. Use this. So where 4 pi is a dimensionless constant, okay? And at the place of force, you can write mlt minus 2. Q1, Q2, 80, 82 times. Understood, bacho? For charge, we can use 80. See this. Electric charge, we can use 80 here. Understood? So 80, 82 times. Epsilon, we don't have dimensional formula. R square is L square and 4 pi is a dimensionless constant. You can ignore 4 pi. Why we are ignoring 4 pi? Because it is a dimensionless constant. Could you understand that? Any doubt? Hello, any doubt? Anyone, any doubt?
No, sir.
Okay. So we got dimensional formula of epsilon naught as m minus 1, L minus 3, T4, A2. Understood, everyone? Very important, and believe me, this is easiest way. It is 100% correct, and this is the fastest way to find dimensional formula of epsilon naught. Okay. Now the fifth is dielectric constant K. Dielectric constant K. How to find dimensional formula of dielectric constant? It is dimensionless, bacho. It is dimensionless. Okay. Because K is equal to epsilon upon epsilon naught epsilon R. ठीक है. अब ये सब क्या है तुम सोचना deep में. We'll talk about it in the particular chapter. Okay. I'll give you a quick revision of class 12th as well, so don't worry. We'll keep it starting. I'll keep you teaching again and again. Okay. I'm always with you all. I will never leave your hand. Whatever you need, I will be with you always. Okay. Understood? But you should keep practicing daily. Don't do like Anvit. He did 30 question in a month. Don't practice this much. This is too much. 30 question per month. Oh my god. इतना थोड़ी करना है भैया. क्यों अनवित? तुम्हें क्या लगता है? मुझे कुछ पता नहीं है. चल now, resistance. Dimensional formula of resistance. But Anvit is good. At least he attended this class. Okay. Now let's try to find the dimensional formula of resistance, electrical resistance. I think the fastest way to find dimensional formula of resistance is again by power. Power is equal to I square R. Do you remember this? So power has dimensional formula ml square T minus 3 because power is equal to work upon time. Work has dimensional formula this and time is T. So power ml square T minus 3. I square means A square and R. You transfer A square other side, you will get A power minus 2 ml square T minus 3 A power minus 2 R. Now I want to tell you one interesting fact. The dimensional formula of RC. 7. RC. Resistance into capacitance. Anyone remember? Let's put value of R. This is dimensional formula of R. Now let's bring dimensional formula of capacitor. This. Let's copy this.
E square.
इसको इधर पे पहले मैं साफ करूं फिर यूज करेंगे. Okay, now multiply what you are getting. A gone,
T.
L
T.
gone, you got only T. So RC has dimensional formula of only T. So RC, that's why RC represent say time
Time
constant.
constant.
Time constant. Okay. Oh, so lot of quantities are left. So tomorrow we'll finish writing dimensional formula of all the most important quantities, and tomorrow we'll start solving a lot of numericals based on the dimensional analysis. And while solving numericals, I'll keep explaining you theories. Okay, understood?
Yes, sir.
So
Yes, sir.
not tomorrow, day after tomorrow, and we will increase the time of this class. As attendance will increase, we'll increase time of this class to 90 minutes. And the next plan is that today, what is date today? 15 December. 15 है ना आज? क्यों विशाल?
Yes.
Today is 15 December, and see what is my plan. After completing semiconductor, Babho sir will teach complete 11th NCRT part 2. Part 2, and I will teach complete 11th NCRT part 1. Part 1, but my speed will be high, and I'll more focus on questions because I believe your theory portion is very good in NCRT part 1. Am I right? Theory portion is okay in NCRT part 1. Yes or no?
Yes,
Shreya?
sir.
Shreya
Yes,
said,
sir.
Yes.
so we will focus more on questions and we'll do theory. Speed will be high, and Babho sir will teach theory full. Short में पढ़ाएंगे लेकिन theory. Speed will be according to you. It will be low, and there will be questions, a lot of questions, no doubt. Okay, so this is how we are planning to finish class 11th as early as possible. I believe 10th Feb we'll finish entire 11th. Entire 11th, can you believe? Entire 11th. And meanwhile, we'll start a revision of class 12th as well. So if you believe on us, keep working with us, have faith in our team, keep attending all the classes, keep doing practice. Okay, we will get full marks in physics. Believe me. I'll teach you everything required. I'll teach you fast, but it does not mean that I'm going to leave anything. As you have understood in the today's class, I am telling you everything possible. In the same way, I'll solve every possible numerical of your Allen module. Okay. you also start revision by your own of NCRT part 1. So today's task is units and dimensions. Okay, Shreya? Today's task, unit and dimension, and please solve a lot of numericals Anvit. Okay? Sivagni, solve module again. Okay, Arshita? That's it for the day. Bye. I hope you enjoyed my class. Bye-bye.
Bye.
Please like and share.